Thank you. Thank you for the opportunity to present here today. This gentleman's job is to inspect vines in a vineyard. He inspects the grapes, the leaves, the tendrils, everything on the plant. He can look at about 150 vines in a day. It's about a tenth of an acre. A person like him is typically a viticulturalist, but not always. If you looked at specialty crop growers around the world, this job of inspecting plants on a continuous basis intensely is vital to the success of not only grapes, but tomatoes, cannabis, apples, peaches, pears, you name it. Continuous, detailed inspection is essential to the success of that crop. Drones have been tried, but the problem with specialty crops and drones is you can't see below the canopy. You can't see the detail you need to see. It's why human inspectors are used. The problem with human inspectors, there aren't a lot of them, so they can't cover much. Again, in this case, a tenth of an acre. They are expensive, it's tedious, and also highly subjective. Experts disagree, but there is a way forward, and that's with us. We use a camera instead of a person to image the plants. The camera you see here is a stereo lens to allow us to see depth, and its own light source to allow it to capture extremely detailed images. You put that camera really on anything that moves, that happens to be on the farm. This is an example of the various vineyards around the world that use our camera, and they've used the vehicles that they have handy. You don't have to drive in any special way, in any particular way. You capture the images on the device. Once the camera then sees a friendly Wi-Fi, all that data goes up to the cloud, and that's where our deep learning kicks in and does its magic. What we're doing is we're looking at the plant in its entirety, and we're looking at everything on the plant. And when I say everything, I mean it down to the level of counting individual grapes. We're sizing those grapes. We're even looking at mold on those grapes. This is just one example of what you see. It's an unprecedented level of detail, and it's essentially everything that that viticulturalist is looking at and characterizing, we are also characterizing. So the way to think of it is, we know what the plant is, we know the grape count, the shape of the clusters, the density of the leaves, but then we also know whether or not there's mold on there, disease, infestation. My motto is, if you can see it, we can see it. This would be a roll-up of all that, but really the point of this is the level of specificity with which you can manage a plant. Right now, you can manage to the acre. A typical farmer can manage to the acre, pick your crop. This changes agriculture, takes precision agriculture to its logical conclusion, which is you're literally managing to the tree, to the bush, to the plant. We started out of Carnegie Mellon University Robotics Institute. After a decade of research, we got a grant from ARPA-E through a project called the Terror Project. We looked at a whole bunch of sorghum. That money launched the company in 2019. We then went into about a dozen farms, all of which were in the United States, mostly grape growers, received another $250K from various grape entities, not only in the United States, but one in Europe. We also got additional grant money. And then we hit the ground running in 2021, where we're now in 16 vineyards in 3 continents, and also a blueberry grow in Peru. We finished first half of the year with about 180K. We'll finish the end of the year with about 300K in revenue, really our first year of operation. We're in blueberries, as I said, we're in table and wine grapes. We're just expanding into blueberries in Peru. We'll be adding other blueberry grows in South America. In 2022, we're gonna look at a third crop. We don't know what that will be, and we'll have bookings about 1.4. We did receive $1 million grant from NASA. That may seem a little odd in that list of customers. Let me come back to that. And then in 2023 and 2024, we'll be moving into outdoor grows, vertical farms, and probably some other crops as well. The NASA project is one example. We got $1 million grant. So the camera I showed you, we got a grant from NASA to build a version of it that's much smaller, that will be launched into the ISS within 20 months. And we will be inspecting crops in a grow that exists in the ISS right now. The version on the right is our humble variant, duplicate really, of the NASA grow in space. And so we put a version of it in our humble offices in south side of Pittsburgh. We've got a great team of Carnegie Mellon researchers, scientists, engineers. We're fortunate to have access to Carnegie Mellon. George and Tim licensed this technology as co-founders. I joined as a serial entrepreneur myself, having done this in a third AI company, second one using image processing. We're also joined by Jason Simmons, who had a who's head of products here, but has a similar role at Uber ATG, the autonomous group here in town before it got bought by Aurora. And then we have a team of Carnegie Mellon computer scientists as well to augment our team. I very much appreciate the opportunity. Thank you.